Okay, in this problem, we want to find the length of the arc for rt is equal to the vector 2t, comma 3 sine t, comma 3 cosine t from the point 0, 0, 3 to 4 pi, 0, 3. So first, I'm going to take you guys to the formula of arc length. And the formula is like this. So we will take the integral, we do the square root, and we're essentially taking the norm of each component. So let's do it for our problem. So we want to know how can we get the point 0, 0, 3 and 4 pi, 0, 3. Obviously, if t is 0, we would get 0 for this. 3 sine 0 is also 0. 3 cosine 0 would be 3. So this point would occur at t is equal to 0. Likewise, how can we get 4 pi? We can get 4 pi by doing by having t is equal to 2 pi. So 2 pi would give us 4 pi. 3 sine 2 pi would be 0. 3 cosine 2 pi would be 3. So that's correct. So our 2 points occur at t equals 0 and t is equal to 2 pi. And so the first thing in order to get the arc length would be to get the derivative of rt. So 2t, the derivative would be 2. 3 sine t, the derivative would be 3 cosine t. 3 cosine t, the derivative would be negative 3 sine t. Next, we will get the norm. So we do the square root, and we square each component. So 2 would be 2 squared, so we get 4. 3 cosine t, we square that, so we get 9 cosine squared t. And then we do plus negative 3 sine t, we square it, we would get 9 sine squared t. And now we use a trig identity. So cosine squared and sine squared would equal 1. So we can say that this right here would equal 9. So we would have equal square root 4 plus 9, so we get square root of 13. This is our norm. And so the square root of 13 is essentially this, and our a and b will be 0 and 2 pi. So we're almost there. So the arc length would equal the integral from 0 to 2 pi of the square root of 13 dt, and now we simply take the integral of it. So the integral of square root of 13 would simply be t times square root of 13, and now we insert our 2 pi. So our final answer would be 2 pi square root of 13, and that's all we need to do.